Whenever you're ready.
Good afternoon. My name is Travis Dawson. I'm also with Task, working on that IV&V services contract. I'm going to talk today about using assurance cases in planning and execution of NASA IV&V projects. As I was kind of glancing through my slide deck this morning, just to kind of remind myself what I was going to say, I realized I have no idea what I was thinking when I put together 36 slides for a 30-minute presentation. There are a few title slides. It's going to be tight, so to avoid having to speak at hyper speed and not be very intelligible, I may actually leave out some of the later material, which is kind of more reference anyway. So we'll see if we can get through it.
If there's anybody on the line that has their speaker on their computer open, could you please mute your speakers? We're getting some echo. Okay, go ahead.
The echo is coming from the main line.
I think we're good now. No, I still have an echo. Where's that coming from?
All participants' lines are on mute. It's just coming from the main line. Everybody can turn off their cell phones, Blackberries, that usually don't.
All right, thank you.
So do that. Okay, so I'm going to start out a little bit of the history of evidence-based assurance at NASA IV&V. So, evidence-based assurance, by which I mean providing mission and safety assurance based on documented objective evidence, is one component of the NASA IV&V program mission statement. For years, though, NASA IV&V managers have struggled with exactly how best to do this, how best to provide evidence-based assurance. Assurance, in many cases, is presented as the absence of a negative, lack of flaws. I provided assurance for this launch system and it didn't blow up, that kind of thing. Whereas providing assurance as a positive product is a little bit hard to get your hands around. I'm going to use throughout this discussion the following definition or working definition for evidence-based assurance. Providing assurance through a structured argument based on evidence that some mission need will be met. And I contrast that with what I call process-based assurance. Process-based meaning we develop a process for doing engineering work, producing a product, and then we ensure adherence to the process. Since the process was designed to provide quality products, if you follow the process, then by definition you must have provided a quality product. And if you put it in those terms, it sounds a little bit silly, but I would assert that that's actually how we usually provide assurance. For example, we have peer reviews, we have tabletop reviews, we have QA, we sign off on things, and we're really measuring adherence to the process rather than directly measuring the assurance of the product. So also a little bit of terminology still. Evidence-based assurance is the need, as I've described it here. And this discussion should be talking about using assurance cases, which is one methodology to provide evidence-based assurance. Okay, so since the NASA IV&V program was founded in 1993, there have been a very large number of activity types used in IV&V, and many of those activities depend on subject matter expertise. There's a lot of different subject matters, areas that we could be talking about here: software, hardware, different types of missions, various system domains, UNIC, etc. The level of documentation that we provided for these analyses is pretty dramatically from project to project. Human-rated missions typically produce more detailed documentation. One example there is following the Columbia disaster, IV&V produced a report that was over 1,500 pages long, and lest I be accused of measuring by volume, again, it was a very detailed report, a lot of technical discussion on the analysis performed and the supporting detail. That's not always the case, though. Not all IV efforts have been as well documented. And not only human-rated missions, even the other missions sometimes very well documented. But the fact remains, what is not very arguable is that the level of documentation generated is consistent from project to project. And from time to time, that analysis is consisted of subject matter experts applying their expertise, reviewing documents, writing issues, and then simply collecting the issues that they've generated is the sum total of the documentation. It doesn't meet program needs. I mean, even if it's correct, there's no way to prove that. It's not reviewable. It's not repeatable. Now, I want to make sure, because there's a little bit of baggage associated with this concept of subject matter experts. It's not my assertion that subject matter expertise is not needed or valuable. It is both needed and valuable, but it's not sufficient. So it's not just lack of documentation. The other aspect of evidence-based assurance is that unless you are using a structured argument to make an assurance claim, then you may document your process very well, but you're not necessarily providing evidence-based assurance. Again, so kind of like with the subject matter experts, documentation is necessary but not sufficient. We have, over the recent years at IV&V, placed a significant emphasis on providing more documentation, or at least more consistently across all our projects. But we haven't placed as much emphasis until recently on performing evidence-based assurance in that structured sense. You know, for example, using assurance cases. Okay, let's talk about assurance cases themselves briefly. So, assurance case basics. An assurance case is a type of structured argument. It has structured assurance cases themselves have a large body of literature in academia and industry. The standard we use is the IEEE standard 15026-2-2011. And in that standard, it defines 3 elements, which is a subset. There's a couple other elements, but the 3 elements: evidence, argument, and a claim. So assurance cases provide the concepts of the vernacular, and again, the large body of literature. And evidence must be both objective and documented in order to support the resulting argument. So this is really just a terminology side. There's not a lot of meat here. It's really just to set up a structure for what an assurance case is. It's evidence, documented evidence, that supports an argument that allows you to make a claim. And that, taken together, is called an assurance case. Here's the IEEE standard, which is itself an adoption of an ISO standard. The standard does actually introduce a couple of additional concepts in addition to the evidence, arguments, and claims I discussed, the concepts of assumptions and justifications. But I call my terminology, the evidence, argument, and claim is kind of the core assurance case, and I think we can have the conversation with just that simplified view. Okay, so assurance cases in IV&V. So within IV&V, the claims we're talking about here in the assurance case directly correspond to assurance goals. So the IV&V activity is where the evidence is identified and collected, the argument is built, and then that supports actually all 3 elements of the assurance case. But the way we're doing it here, we perform an activity, collect evidence, make an argument, make a claim. We certainly don't have a resulting assurance case that just is the result of whatever happens to be supported by what we do, obviously. We want to get out in front of it and use this as a planning tool. So this is kind of a different view. On the left-hand side, you say this is your intended assurance case. This is the assurance case I intend to prove or intend to support by my activity. And the term I use is walking through it backwards. So rather than evidence supporting an argument, supporting a claim, if I want to make a given claim at the end of all this, what argument do I need to be able to make, and what evidence do I need to support that argument? Once I know what I'm trying to collect, then I can plan my IV&V activity. And so, just putting it all together, we start out on the left as part of the planning process, we execute, and then we come up with what I'm calling a resulting assurance case, as distinguished from the intended assurance case. And of course, in an ideal world, they would be the same. But in a non-ideal world, you may have to back off of the claim that you intend to make in some sense. So conclusion here, application of insurance case methodologies can and should provide a means of providing the product planning gap. Now, unfortunately, a little bit of a slide error here in that I didn't, in an earlier version of the package, I introduced the assertion that there is a gap in IV&V planning processes by which the IV&V project planner does not really have a lot of support in determining which activities select in some optimal sense. And this is a way to help close that gap, which unfortunately I didn't introduce the concept of the gap before I told you how I was going to close it. So we have basically these 6 steps here, which are just kind of a summary or a repeat of what I said earlier in the diagram. 1, 5, and 6, so selecting the project goals, defining the activities, providing execution details and directions to the analyst performing the work. We do that already. The 2, 3, and 4 are the gap, using my terminology from a moment ago. So how do I know what claims I'm trying to make and what evidence I need to collect? And right now, I think that's based on experience, engineering expertise, management expertise, but we don't really have a formal process for performing that. So a quick example of an insurance case. So we have a module M. In this example, we have a requirement for a module M. Output Q shall always be greater than or equal to output R for all input sets. It's stateless. And what we have as a given is a developer provided truth table for module M. So we're going to make the intended claim, and incidentally, it's probably pretty obvious that the intended claim looks a whole heck of a lot like the requirement, right? You can, in many cases, take a goal or a requirement, and you can simply by rewording and changing the context, use the exact same statement. So for module M, output Q is always greater than or equal to output R. So the requirement says it shall be that way. The claim says it is in fact that way. So the argument I plan to use is by inspection. By inspection of an exhaustive set of cases, we can confirm that Q is greater than or equal to R in all cases. And the evidence I'm going to need for that is the table of outputs for all inputs. So this is my intended assurance case. I'm going to go through the work of actually doing the analysis. Or excuse me, I'm going to plan the activity, then I'm going to do the analysis, and then I'm going to come up with the resulting assurance case. Now this is obviously a pretty simple example, but as usual, you have to come up with something relatively simple to make the point. So a couple comments on this example. I use a requirement as my input. Do we really go through this process for every requirement? Not necessarily. I mean, if you've got a 5,000 requirement set, I don't want to build 5,000 insurance cases and track them all and so forth. There may be individual requirements for which that's appropriate. Some requirements are very high level, very important, or for some other reason it's appropriate to treat it individually. What I assert is that in the context of IV&V activities, there's generally a one-to-one relationship between activities and insurance cases. I did pick a simple example, as I said a moment ago. Even if you don't use a formal insurance case, the same thought process can still help you do your work. If you, for example, in this hypothetical 5,000 requirement set, we're going to analyze each of those requirements. You might not build an insurance case, but you could still capture in your analysis notes and spreadsheets and so forth, verified by examination of an exhaustive IO table that this is true, gets all the same work without some of the overhead. But that's not the only way, that's not the only argument. I mean, insurance cases doesn't assert itself to be the only way you can do it. So the example I just gave, again, approach A was the exhaustive review of the IO table, which is the one we went through. You could generate an IO table from a executable model. You could generate a model from designer requirements. You could prove directly, mathematically, from the designer requirements it's true. Or you could exhaustively exercise the code in a test environment. Last one, of course, to people who have been around the block a few times is readily available to us for any realistic complex system, and etc. So there are many number of ways to do it. You must not overstay with your claim. In other words, you have to take into account the evidence that you're seeing. So if you, for example, make some claim about a requirement set or a design and then prove that, you cannot make a claim about the system, because the design is not the system, the requirements are not the system. Okay, some real world considerations. You've got to elaborate the assurance case, so it isn't, you don't usually just stop with one, you don't stop after writing an assurance case. If you want to make an assurance claim about a system that will perform safely and meet its mission requirements, you've got to elaborate that down into lower level assurance claims. And there's a number of ways to do that. And in fact, that's one of the areas that we're spending the most effort on right now within IV&V is exploring the different ways in which the assurance claim can be decomposed and elaborated. So, simple diagram here. So if you have a claim and it's supported by two subclaims, so if I say the mission will perform as expected, and then I have a subclaim that says the launch system, subcomponent of the overall mission system, will perform as expected, the on-orbit vehicle will perform as expected, and then the ground support station will perform as expected. Those will be three subclaims to support the claim. Then of course there will be further elaboration below that. And each of those subclaims, at some point you quit supporting claims with subclaims, and you have to actually build the assurance case. So each of those is then an assurance case, and then the overall system of all claims. Of course, this is two subclaims supporting a claim where you could have a much larger number of subclaims supporting some ultimate top-level claim. This calls an assurance case network. Subclaim is a claim, so in the standard, it's treated exactly the same way. It's on a different beast. So iteration, there can be unintended results. Unintended results means we have evidence that conflicts. We have incomplete evidence. We can't really get where we need to be. We can't collect the planned evidence, or the appropriate claim, that the one that emerges is not the claim you set out to prove. And those are things that we all need to consider, because the case where we started on day one with an intent and met that claim at the end of a year's worth of analysis with no variation is going to be the rare exception case. So we need to be able to, any real world usable system, or excuse me, approach needs to account for those real world considerations. So what I assert is that all of those can be handled through the process of iteration. So this is a simplified version of the diagram I showed earlier, the end-to-end process. You know, at each step in the process, basically, as you start to veer off or diverge, you may have to iterate back to an earlier step and iterate on your planning. And in fact, at some point, you could diverge far enough that you basically start over. You say, we're not getting there from here, so let's back up. What can we do? And start again. Claim considerations for IV&V. So the claim structure starting point has definitely been one of our stumbling blocks. In other words, what's our first level decomposition, and then when to stop. So again, the example, like a kind of counter example, so to speak, I said you don't really want to do 5,000 assurance cases probably for 5,000 requirements. Okay, that's kind of bounds me on one end. Where do I stop? Do I need 2, 3? Do I need 3 levels, 4 levels? And of course, in most real world systems, there's no simple answer, no rule of thumb that says you need 3. But what I do say is that, I'm going to just repeat what I had on my earlier chart. In my belief, that you stop when you get to the level of an IV activity. So, for example, an IV activity might be analyzing a given requirements document. So you're going to make a claim the requirements set, captured in the requirements document, meets certain criteria and of goodness. And so that'll be your claim you're making. Then you design activity that intends to prove that. Collects the evidence, makes the argument. It could be that you decompose it a little bit further and say, I'm going to take all the requirements and break them up into subsystems, or break them up into system behaviors, or any other ways to do it. So there's numerous starting approaches to creating claim structure that could be based on project goals, diving into 3 questions, which are, does the system perform as it should? Does the system not do what it's not supposed to do? and how does the system perform under adverse conditions. And you've probably heard that before now if you've been in on the workshop from the beginning. That's one way to decompose it. The architectural decomposition, that's what I'm calling subsystems, system level behaviors, attain proper orbit, etc. So this is still not a real decomposition, but it's intended to make one point, which is that it's totally legitimate within the standard and with common sense that you can have multiple top-level claims. So the DCC claim, the system claim, is the union of the top-level claims. They don't have to all roll up. So you can make a claim the EDL will perform correctly. So that's that behavioral view. A claim is a requirement to support the subsequent phases. That would be a life cycle view, a software development life cycle view. G&C will perform as needed would be a subsystem or an architectural view, and system will perform as needed is a top level or a Q1, Q3 type view. And so the point is of this diagram is to show that simply making an additional decomposition or an additional top-level claim does not mean the work has to be repeated or is somehow not compatible or mutually exclusive with the work needed for a different claim. And in fact, you can have multiple sets of evidence supporting multiple arguments, each supporting multiple claims, and that's totally legitimate. And there's an efficiency that you can gain there. This is some of the material I said was kind of reference, and I'll go through it fairly quickly and just kind of point at some things. The IEEE standard, which is what I said we were basing our work on, does not specify any notation, certainly no graphical notation. One standard of graphical notation that we are using so is called goal structuring notation, or GSN. It actually predates assurance cases. It's been in use since 1997. The current standard is draft as of May 10. What happened?
Oh, I lost network. Go.
Okay. So supported by a variety of tools. Unfortunately, GSN doesn't directly support the IEEE standard. In other words, the 5 elements that I discussed earlier, claims, arguments, evidence, justification, assumptions. The GSN elements are goals, solutions, strategies, assumptions, contexts, and justifications. And just to make it like more complicated, the justifications in the IEEE standard aren't the same thing as justifications in GSN just because they have the same name. So GSN does define a graphical representation. It does add the idea of linkages. The linkages aren't expressly called out in the IEEE standard, just the individual nodes or elements. And the total network is called a goal structure as opposed to what I was calling an assurance case network previously. Claims, arguments, or evidence, and ASCE. Claim, argument, evidence certainly looks a heck of a lot more like an IEEE assurance case. It was created by Adelard and supported by their COTS ASCE tool, Assurance and Safety Case Environment. So ASCE is a tool. It also introduces its own notation. And in fact, ASCE supports 3 different common notations. It does provide, it's a tool as opposed to a graphical standard. So it also adds some functionality. Yeah, and so it does support both GSN and CAE. I'm not gonna go through this in any detail whatsoever, but here's where I tried to compare the 3 different standards that I'm saying is in use. And again, like justification, there's really no IEEE element that corresponds with GSN justification. And there's a GSN element that corresponds with its IEEE justification, but it's called a context. So again, just a little bit of reference there if it helps anybody. Structured assurance case meta model is developed by the Object Management Group, OMG. Previously, I think Object Modeling Group. SACM is a combination of 2 other meta models. It includes GSN and CAE into a formal model itself. And ASCE, the tool we talked about on the previous chart, is in fact adding support for SACM, which is the combined model. Oh, that's interesting. So what have we done here?
Do you have animation on this slide?
I don't think so, but I keep hitting right and I'm not getting anything. Unfortunately, I didn't bring it. I think it got truncated there. We were getting close to the end anyway, and we did most of the meat. I want to go ahead and open it to questions now. We've got 5 minutes left, and if we can find the other slides, great. Otherwise, let's go with questions. Any questions in the room?